Today's Nature Talks is going to think about how does technology impact the earth around it? What choices do designers need to make? What problems do they need to solve? Some questions I have are, how does this building footprint impact the soil and the Atlantic Ocean? The Atlantic Ocean water comes right behind this building. How does this building impact the air, the atmosphere? How is it designed to withstand weather? How does this building impact the water supply? Science is the study of nature. Humans use nature to design technologies to make their lives better. Let's talk about technology today. Today, you're going to listen to Mr. V. He's going to be discussing some of the production problems that they needed to solve. Problems aren't always bad things in science and engineering. Problems mean that you are creating or designing something new. So here is what's going on. All the different problems that you have to consider when you're designing a house. All the materials. And this is beautiful Westerly, Rhode Island. I can tell that it's low tide. How can I tell that the tide is low? Low means that the water is out. It's not close to the shoreline. I wonder why that happens. When you're deciding to put a building in a space, what do you have to consider? How do you have to work with the land? How do you have to work with the soil? What about water, plants, and the living things? You're taking space from other living things. So what do you need to do so that they can survive? And this is the house dog, Piper. Say hello, Piper. So I have lots of questions here. I wonder why they have to put this product on called sheetrock and then tape it. And I wonder why they have to use these protective devices for lighting. And I wonder what this little cubby hole could be for with the arrow.
Lights above, and I kind of beat on them.
Everything in this room is shapes, is math. What kind of shapes do you see?
It's 3.5 inches wide and flat. The corners, the edges of it just have to go around the window. The casing fits on. Oh, okay, it's gonna come out. You're gonna be out 3.5 inches wide. That's when we get down to the sill. What's that? You're gonna have a window sill that's gonna stick out probably about 6.5 inches out. 45, everything so it sits nice and tight.
Yeah. I kind of like the way you describe. Every sill I've seen lately,
The like 7-inch window stool.
Electrical cords are capped off so that they cannot conduct electricity and cause a fire. Do you notice the blue caps that are covering the wires? I just found these very cool tools. They almost look like crutches. And it almost looks like someone might put their foot in there. I wonder if they are used for something. Let me back away so you can see. I wonder if the sheetrockers stand in those so they can sheetrock and tape the ceilings. So why is the sheetrock in this room a different color?
This is moisture resistant sheetrock due to the steam from the showers. That's the bathroom fan.
Which one's gonna be, are these, what are these, sinks? Double sinks?
Yes.
I can see there's two different ways that water comes in and goes out.
Yeah. Hot, cold, same thing in your shower stall's all gonna be tiled. That's why it's cement board in here. This is all cement board.
And I noticed that it says moisture resistant plus. Can I ask you a few questions?
Sure.
So what did you have to consider when you were laying the footprint of this house? How did the land around it or underneath it affect what you were doing?
There's certain flood restrictions here, so the house had to be 6 feet above what they consider the flood zone. The water could come up to just below the floor. That's the worst possible circumstance.
And what did you do to protect the water? Because I know that putting a house here might damage the water. What did you have to do for that?
We bailed and pumped all the water when we were putting these two filters to keep the water clean that was coming out of the ground.
So you wanted to make sure that the water that's reaching into this ocean area here, or is this an ocean area, or what is this called?
This is the
You had to be careful so you don't release contaminants into the bay. And soil, loose soil is a contaminant.
And even the concrete, when we poured our concrete, we couldn't lubricate the panels with any type of oil. We had to do with a special type of vegetable oil.
So as you can see, this space is shared with many other creatures. There are gulls out there, there are shellfish, lots of aquatic insects. So Mr. V, what do you have to consider with weather, specifically wind? Because I know this area can get some hurricanes, so how did you design this place?
There's special metal supports in all the corners on the front of the building facing the bay. They're 18 inches wide. It helps with sway.
And I know you told me once something about hurricane clamps or something. Did you have to use?
Hurricane clips on all the rafters that tie it into the house. Everything, every framing member from the foundation all the way to the roof has metal connectors to connect each floor, every level, all the way up.
And planning even involves putting a railing system on this deck. You have to have a railing system that is up to code so that people cannot be in danger. On the side of the house, you see little orange flags marking out the septic system. Septic is where your toilet and sink water goes. You have to protect the land and the ocean from that. This house is special too because you cannot have underground gas lines. You must use propane tank. Everything possible is done to protect the environment. Hay bales are used to protect from soil erosion. If you look closely, you can see some rocks there, and having that soil run into the bay is bad for the health of the water. The black plastic material you see also does the same thing. It helps to prevent soil from washing away into other areas. I hope you enjoyed today's field trip with Meriden's partner, Fiderio & Sons. I'm going to ask you to go and take a look at some technologies. Think about how does the technology affect the land, the water, the air? Why do engineers need to protect these special spaces? Final question for you. Why is this house built so tall on stilts?